So today we are going to discuss the bunch of models called autoregressive models. So marami yan sila, no? Yung AR, yung MA, yung ARMA, tsaka ARIMA. So when you hear the word autoregressive, what comes to your mind? Diba? Kapag sinabi natin autoregressive, ang ibig sabihin, there's of course two words here. First word is auto, and we have regressive. Okay? It just means that for this model, we're actually applying a regression model. Okay? So I think familiar na kayo sa ibig sabihin ng regression models. So regression model is yung na-encounter nyo na sa stat, di ba? So, linear, ordinary, least pairs, right? So you are trying to uh, predict an outcome variable with independent variables. You use that, you build an equation, linear equation. It's called linear because it's linear in the parameters or linear in the coefficient. And you're trying to predict the outcome variable. Kaya lang itong autoregressive, ang ibig sabihin, auto. So it means that you are using the same data to predict that data. Or you're using a part of that data to predict your data. That is actually one of the characteristics of time series. Because what you want to do in time series is you want to predict or to forecast. And what are you going to use to forecast the values in the future is you use the existing values or the existing observations. So kaya siya autoregressive. Unlike doon sa usual na regression wherein you use different variables to predict another variable, itong autoregression is same variable pa rin, but you're going to use the past observations to predict or the present or the past observations to predict the future. And we are going to discuss the different autoregressive model. Pinakauna is yung AR, then the MA, and then the ARMA, and then the ARIMA. So let's have a sort of a review of a time series. No? So, kasi maintindihan natin, mas maintindihan natin when natin gagamitin itong autoregressive model kung alam natin kung ano yung characteristic ng ating time series. Marami na kasi ngayong mga tools na nag-exist or yung mga software na nag-exist. It's very easy to run these models on your data. But of course, this software always gives you the result. Okay? Kahit mali yung pagka-apply niyo, it will always give you a result. So it's very important that you understand first, kailan mo gagamitin itong autoregressive model, ano yung dapat characteristic ng time series so that the autoregressive model is applicable, and how. Question is, how do you apply this? What assumptions that it must first satisfy? What's the form of the equation? And how does it generate forecast? Okay? So in order to do that, review muna tayo ng time series. Then we will review some terminologies and categories. And then we will review the white noise. And we will review the random walk. And then we review time series analysis. And then we go to ARIMA models. Then we're going to use ARIMA modeling to solve a problem. So it's called a toy problem because it's a small problem. Okay, so let's first review what is a time series. A time series, balik-balik na ito, pero it's good to be reminded to this, right? So a time series is a sequential set of data points measured typically over successive time. So it's just a sequence of data indexed by time. So if you have a data that is observed over time, then that is an example of a time series. So an example of that is sales per day. So if you own a sari-sari store maybe, and you want to keep track of the sales per day, starting from January 1 up to December 31, then you record the sales per day. Then what you have at the end is a time series data, which is observed per day. Yeah? So there are many methods to analyze time series data. And they all have the same purpose. And the purpose is to extract patterns and to extract meaningful statistics and other characteristics of the data. Yung natutunan natin sa time series decomposition methods, those are actually extracting characteristics of the data. So yung seasonality, yung trend, di ba? Yung variance, yung level, those are all characteristics of time series. And what we want is to extract those information if they are present in our time series data. We can also have we can also represent a time series not only in the time domain. So when do we say that a time series is in the time domain? It's very easy because if you plot the time series and the x-axis represent time, then that is a time domain representation. Okay? And we have a lot of methods that deals directly with the time domain. And those methods or those, and we call those as time domain approach. Okay? And it looks at what happened today or how does what happened today affect what will happen tomorrow. So sometimes it looks at, okay, lag relationship. Pag sinabi nating lag, it means that we are looking at consecutive times. Okay, so when we say lag 1, we're looking at previous. If we're looking at the lag 2, then we're looking at the 2 previous. Okay? So yun yung lag. And usually, what we do is we compute the autocorrelation analysis or autocorrelation function. Sa frequency domain naman, instead of yung x ay time, x is actually the frequency. And it's very useful if we study cycles through periods of expansion and recession. So, doon sa time, ang tinitingnan is lag relationship. How does the past relate to present? How does past present relate to the future? Yun ang tinitingnan. Whereas a frequency domain, it actually looks at cycles. So, periods of expansion and periods of recession. Yeah, the frequency. Example of that is spectral analysis or wavelength analysis. Okay? For our course, we will deal with time domain approach. Itong frequency domain approach, usually, they are covered in another course. Ito yung tinatawag nating signal analysis. Because sometimes it's useful to look at the frequency characteristic of the signal rather than the time domain. Or it's more useful to look at the frequency domain rather than the time domain in order to understand the signal. Because sometimes what we are interested is that we try to break down a signal into its constituent frequency. Yun kasi ang gusto nilang they try to break it down into individual frequency. And understand one frequency. Once you understand that, then you can combine it to get the original signal. Yan yung ginagawa sa frequency domain. Pero dito sa atin, we will use time domain or time domain approach. But there are also other categories aside from the representation of the time series of a series in different domains. Meron din tayong other characteristics which can be univariate or multivariate. So pag sinabing univariate, one variable, right? So all the records comes from one variable. Now, pag sinabi naman nating multivariate, the records come from more than one variable. And that term, and we call that as multivariate. Meron ding linear versus nonlinear. So, linear siya based on, paano natin ma-determine kung linear or nonlinear? Based on the relationship of the current value of the seed. Kung linear ba siya or nonlinear function siya of its past observation. Well, it could be linear. It could be nonlinear. Depende kung ano yung relationship. Okay? Pwede din siyang discrete or continuous. When we say continuous, you are measuring the observations at every instance of time. Whereas in discrete naman, you measure it at discrete points in time. Ano ba yung example ng? Kasi usually, ang na-encounter natin, di ba, yung mga discrete yan eh. Di ba? It's either every day, every year, or every week, or every month. No? Pero ano ba yung example ng continuous? Example yon is yung napanood natin sa movie, yung mga malapit na mamatay. Di ba? Meron silang, ano nga tawag dyan? Yung ECG ba yan? ECG? Di ba? Yung ECG natin, yan actually yung graph, no? Ng activity ng ating heart. So it monitors it in real time. Hindi siya in discrete time. Okay? Another, di ba, pag ma-observe natin matay na is, buhay pa. Pero pag, tsugi na. Tama? And that is actually continuous. Right? At that time, malaman mo patay na siya. Hindi ka pa maghintay ng another time para malaman na patay na. Okay? Yan yung mga discrete. Ay, continuous pala. Okay? So, but for this lecture, we will focus on univariate, linear, discrete time series. Because yan yung pinaka-application talaga ng autoregressive model. Later, if we want to extend this, for example, if we want to add more variables, then pwede nating i-expand or pwede nating i-extend ang ating autoregressive model to include more variables. And yun yung topic ng dynamic regression. Okay? Pero dito, focus muna tayo sa univariate. We assume that they have a linear relationship, the present or the current value has a linear relationship with the past value. And discrete, wag muna natin ano yung continuous. Okay? Yes, intindihan ba? Of course, kahit continuous pa, no, we can always discretize that. Right? Okay, so another review, time series can be described into 4 components. Okay? Trend, seasonality, cyclical, and irregular components. Trend is the tendency of time series to increase, decrease, or stagnate over a long period of time. So example of this is shown here. Kita nyo, seems that the time series is increasing. So, meron siyang trend. Ang trend naman niya ay increasing. Right? Seasonal variation naman is component that explains fluctuations within a year during the season, usually caused by climate and weather conditions. So, ganyan ang pag-identify para ng season, no? Seasons actually correspond to point in time kung saan nagpa-fluctuate yung ating time series. Ganyan ang pagkakaiba niya sa cyclical. Kasi ang cyclical, the cycles, the up and down, does not correspond to points in time. It can be, hindi natin siya ma-predict. Hindi siya determined by month or by day or even by week. No? Hindi natin siya ma-predict. Pero ang seasonal, alam natin, ma-pinpoint natin kasi regular ang kanyang pagtaas, pagbaba. And usually, it corresponds to a point in time. An example is yung sales. Yeah. So usually, ang sales, tumataas yan siya during December. Then bumababa siya maybe around February. Okay? So we can always expect na pag December, mataas ang sale. Pag February, mababa ang sale. And that exhibits what we call seasonality. Okay? So ito yung sinasabi ko kanina na cyclical variation naman, meron ding change, no? Sometimes people confuse this with seasonality kasi. Pero yung pagkakaiba nga sinabi ko na kanina. Diba? And this actually the changes does not correspond to point in time, but to circumstances. And usually they repeat in cycles. And the duration of a cycle extends over longer period of time. So here it looks like this is seasonal. There is seasonality, but no. Because unang-una, hindi natin ma-predict with certainty kailan siya mag-increase. Kailan siya mag-peak. Walang regularity. Right? Or kailan siya magbaba. Walang regularity. So this time series exhibit cyclical variation. So in general, a time series is affected by trend, seasonal, cyclical, and irregular components. We have what we call irregular or random variation. If these variations are caused by unpredictable influences, which are not regular. Because if they're regular, then it's seasonal. And also do not repeat in a particular pattern. Walang pattern, mahirap siya i-describe. No? But andun yung variation. In practice, usually itong mga irregular na variation can cause by incidents. Example of which are war. Example ngayon, may war ngayon, diba? Or strike. Ano ibig sabihin ng strike? Yung mga union, no? Strike sila. Mga labor union nag-strike. For example, usong-uso yan noon yung mag-strike yung mga transport group, no? So bababa yung kita ng mga driver, diba? But you cannot predict when sila mag-strike. Ahead into the future. Diba? Could be earthquake, caused by earthquake, right? Or flooding, or a revolution. No? So these variations are really the same way that we cannot predict war, strike, earthquake, flood, revolution. One day will happen in a particular time. Same thing with irregular variation. So there is actually no defined statistical technique for measuring random fluctuations in a time series. Sometimes what analysts do is they use or they add a term to the model to account for irregular variation. And usually yun yung error term. Okay? So to model the time series, i-decompose muna natin siya into different components and then it can be added or multiplied. So add the different components to get the time series or we can multiply. So ano bang implication pag add? It means that they are independent. The trend, the seasonality, the cyclical, regular variation are all independent and we can just add them to get the original. However, kung gusto naman natin i-multiply, it means that they are not necessarily independent and they can affect one another. For example, no, the seasonality or the trend can affect the seasonality. So it can change the level, no, of the observations. Well, it can be increasing. Example na ganito. Parang ganon ang time series. Yeah. Pag ganyan, meaning nag-start siya sa maliit, yung kanyang fluctuation, biglang naglaki ang mga fluctuation, that could be an indication that trend and seasonality are related or not independent somewhere. Pero kung same pa rin yung level ng increase-decrease, pero nakikita lang natin nag-increase siya over time, then that's just additive lang yan siya. Okay? Okay, there is what we call white noise. So sinabi natin white noise, kung ang ating simple time series is just a collection of uncorrelated random variables. Okay? Pero itong random variable na to, meron siya, random variable na ito is meron siyang distribution. And usually this is 0 ang mean and finite ang variance or constant yung variance. Okay? Then that is white noise. Kung Gaussian white noise naman, the WT or the random variables are independent normal random variables with mean 0 and variance denoted as W sub T independent normal. So anong kaibahan ng white tsaka Gaussian? White. White noise is a bit generic. So hindi siya necessary Gaussian or normal ang distribution. It can be any distribution as long as yung mean niya ay 0 at ang variance niya ay finite. Pero for Gaussian, it means that normal siya. Okay? With mean 0 and variance. White noise sa time series is of great interest because if the stochastic behavior of all time series could be explained in terms of white noise model, then classical methods will suffice. So hindi na natin siya need i-model as a time series or special pa ang kanyang pag-model. But we'll just use the time series, the statistical models that we have learned in STAT1 and AMAT 131. Kung Gaussian white noise or kung white noise siya. Correct? Meaning walang wala talagang trend, walang seasonality, walang critical behavior. It is plain uncorrelated random variables. Okay, let's look at an example of time series which we call the random walk. Okay, a random walk is the process by which randomly moving objects wander away from where they started. Let's consider a one-day process. Okay, the value of time series at time t is the value of the series at time t minus 1 plus a completely random movement. So, for example, meron kang value at time t, and you want to know what is that value from t minus 1. Then, the equation is just t equals t minus 1 plus a random movement. Okay? And that is what we call the random walk. Okay? So, kita nyo ta, xt, x my t, and the error, and the random. Okay? And they have is the constant. Okay? So, yung constant drift factor. Okay? The procedure of using known data values to fit a time series with a suitable model is often useful for future forecasting and simulation. Well, there are several ways to build this time series forecasting model, but we will focus on stochastic process. Okay. So what do we mean by this? We try to model our time series as a series of random variables. Okay? So kung meron tayong observations, there's actually we can look at it, the observations as an instantation of a random variable. Okay? And usually it's discrete and vary over integers 0, 1, 2. Okay? Medyo mahirap siya intindihin. But if you just look at a time series as a sequence of random variables, which are independent from each other, and a specific time series with values, you can look at that as a instantation of a value of a random variable, then that is a time series. Okay? And a collection, since set man siya, di ba? X sub 1 is random, X sub 2 next is random, X sub 3 is also a random variable. Nagkasunod sila, but it's actually a set, no? We call that as a stochastic process. So dalawa, okay? First, they must be random variable. And first and second, they must be in sequence. Or they are ordered. And that's a stochastic process. And while the observed value are referred to as a realization of the stochastic process. Okay? A complete description of time series observed as a collection of random variables, arbitrary time points, provides a joint distribution function which can be evaluated as a probability that the value of the series is jointly less than the n constant. Okay? So it can be probability of ito, di ba, is just a realization lang man yan siya of random variable. So yung kanyang probability distribution is just xp1 less than c1, 2, and so on and so forth. Kaya lang, mahirap itong i-deal kasi nga multidimensional and the series can be long. Therefore, some informative descriptive measure can be useful. So instead of directly dealing the joint probability or the joint distribution function, we will compute some descriptive measures na lang muna to describe the time series or the stochastic process. Okay? Of course, it's possible, but it could be complicated. Okay? And sometimes we use the mean function and other measures. Okay, so what is a mean function? The mean function is defined as mu t. Ay, wala aking. Okay, dapat meron to siyang summation. Okay? So the mean is just, of course, the expectation. It's just x times the probability times the function of x. Right? So usually that's a probability. Right? And for white noise, since the expectation is 0 for all t, for random, so kung white noise siya, of course, this is 0. It means that the mean of a time, pag 0 nga ang mean ng isang time series, ng mga values niya, that's an indication that it's just a white noise. Kumbaga, kung ipa-plot mo siya, the values just varies within 0. Hindi na siya lumalayo sa 0. Okay? So that's white noise. And the mean order of this. Now, for random walk with drift, so therefore, ang makukuha lang natin is just the drift. Right? Or the mean is just the drift. Hindi na natin kasi expectation naman is 0. Kasi nga, random siya. By definition, right? That the mean is 0. So, kukuha natin is yung component lang na drift. Tama? So, yung autocovariance, we can also assess the covariance of two random variables. And then, of course, the autocorrelation between two random variables. Then, of course, pag mataas yung autocorrelation, it means that linear ang kanyang relationship. Tama? And for forecasting, why is it difficult? Because sometimes we'll be dealing with non-deterministic. And we cannot predict with certainty what will occur in the future because it's very random. There's no pattern. Pero, pwede nating, meron tayong pa rin pwedeng magawa. Mas madali kasing i-predict kung ang ating time series ay stationary. So, ano ibig sabihin ng non-stationarity? Yun yung random walk. Tama? Kasi, if we have a stationary, then we just need to predict, we just need to identify unang-una ano yung mean. And then ano yung variation. And that's it. That's all we need for stationary. Pero question, sir, hindi naman lahat ng time series stationary. So, very limited. Tama. But, a non-stationary time series, we have techniques that we can use or we can apply to a non-stationary time series to make it stationary. Exactly. And that is the topic for today. Ay, yan sinasabi dyan sa last paragraph. Most statistical forecasting methods are based on the assumption that the time series can be rendered, I repeat, can be rendered approximately stationary after applying some mathematical transformation. Now, let's look at this various time series here. Let us decide which among these time series are stationary and non-stationary. So let's have A muna. Kayla, what do you think of this time series? Is this stationary or non-stationary? Bakit siya non-stationary? Kasi may trend. How about B? Is this a stationary or non-stationary? Bakit mo nasabing non-stationary? Bakit mo nasabing stationary? Yun lang ba ang tinitingnan? Ang trend lang ba ang tinitingnan? How about seasonality? Meron bang seasonality? How about a cycle? Meron bang cycle? Is this stationary or non-stationary? Bakit siya stationary? So kung titingnan nyo ang graph, actually yung fluctuation niya from the zero, it's already an indication na stationary siya. Okay? Wala namang seasonality. Walang trend. Wala ding change sa level. So therefore, and it fluctuates around zero. Meron naman dito, pero this is unpredictable. Di mo malaman na at this time, ganyan siya kataas. So therefore, that is stationary. Okay? How about C? Yes, is that stationary or non-stationary?
I think not stationary po. Non-stationary, I mean.
Bakit mo naman nasabi?
Kay murag na ay nag-change, sir, from murag ang level good kay first kay nagbaba siya dayon and then nagtaas, so murag ang level good sa kanyang trend.
Level
Kaya
lang ba?
nag-change.
Level lang ba?
Trends niya, sir. Ang trend niya kay and yeah.
Yeah. Correct. So, both level at saka yung kanyang trend ay nag-change. So, hindi siya stationary. Correct. Very good. Okay, how about D?
Okay, Kayla. Ano ang D? Stationary or non-stationary?
Okay, pwede ninyong tingnan ang ang seasonality. Meron kaya siyang seasonality?
Or wala?
Meron, di ba? So, tignan mo yung pag-increase, no? Increase, decrease, 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 then increase, then decrease, then increase. Yeah? So there is seasonality. Hindi lang siya pare-pareho ng pag-increase, ng values ng pag-increase at pag-decrease. Yung level. So therefore, this one is not stationary. Correct? Okay. Good. Okay, very easy. E. Let's have Joanne Capazilio. E. Correct. Bakit? Correct. Good. Okay. Santiliana, F. F. Stationary or non-stationary? Are you sure? Are you sure? Stationary ang F? Correct. Bakit? Dahil nag-change ang kanyang level. Ha? Bakit wala? Pag isa nga sa indication ng walang seasonality is stationary. Yeah? So dito bigla siya nag-change and then bigla siyang nag-trend, nag-increase. So yan ay indication na non-stationary. Okay? How about the G? Datlin. How about G, Datlin? What do you think?
Medyo ano siya, sir, medyo non-stationary. Pero, wait lang, sir. Feel ko stationary siya, sir.
Bakit?
Murag, same ang ang growth ng ng mga graph. Though may taas, tapos may tatlo na medyo maliliit. So I think if like maraming years, siguro same lang yung niya. Same pa rin yung kanyang behavior. Ano ko, sir?
Ha?
Hello, sir.
Wala ba siyang seasonality? Kasi nag-increase, nag-decrease, nag-increase, nag-increase.
Gani, sir. Hindi ko sure, sir. Amo man siya, sir. Pero feel ko, sir, kay murag same good sa letter B, sir. Na murag ang kanyang murag na zoom out lang ni siya na year ni letter G. So murag if more years to come kay murag mag letter B siya, sir, na like small season. Ayun lang ka lang.
Yeah, tama. Well, tama imong ingon nga stationary. Pero namali ka ubisan. Actually, stationary. Pero the reason bakit stationary, di ba ang question ko bakit? Mukha siyang may seasonality, but actually wala siyang seasonality. Di ba? Kasi pag sinabi natin seasonality, we can predict, di ba? Oh,
Dili ba siya murag cyclic, sir? Ay, katong cycle.
Dili po siya cyclic. Makita lang ni mo dira na ang iyahang pagtaas o pababa does not correspond to any time sa year. Unlike sa seasonality na pwede nimo siya maingon nga. It corresponds to seasons like every December nag-increase. Kini wala ka yearly man siya. Ha? Wala man tayo maingon nga for that year. Mubalik ba na nga year? No, it will not come back. Pero pwede tayong balik nga. Kanang season is every December mo increase siya. Ang December man good. Every year na December. And every year makaingon ta nga nag-increase ang season. Whereas kini nga data wala siya per year siya. So that's already an indication na wala siya seasonality. Although natin ma-observe nga nagataas o baba. Tama? So that is actually stationary. Okay? Good. Let's have H. So ang H, of course, it exhibits seasonality. Kung makita ninyo, 1993, 94. So, mo-decrease siya somewhere here, which we can expect again here. And prior to end of 1994, mo-decrease siya. Ito po, prior to the end of 93, nag-increase. So, na siya seasonality. Unlike here na per year ang observation kay 1820, 1830, 1840. Okay? So, in this case, this is not stationary since naa siya seasonality. Okay? And of course, klaro man na nga naa siya trend, naa siya seasonality, and nag-change po ang iyahang level. So, mo niya akong ginaingon sa inyo ganiha na when additive o when, remember na ako ipakita ng equation, kini when additive o when ka mag-multiply. Ang example nga time series nga multiplicative model is kini, itong last. Ini. Kaya ma-observe ninyo, gagmay pa lang ang iyahang pag-increase, pag-decrease. Pero para habang nagadugay, nagatagas, nagatagas yung pag-increase, pag-decrease. Trend o ang seasonality. Okay? Okay. Thank you. I hope na klaro na siya. There are two types of stationarity. First is yung strictly stationary. Okay, anyway, so just read the book and then the slides. And then rewatch this lecture kung merong hindi clear. And that would be our lesson for today. Yeah?
Okay po, sir.